Hi, this is Kendra from Brent, Ozar Unlimited. Today I'm going to talk about foreign keys in SQL Server. First up, foreign key relationships. Let's talk a little bit about the basics. We have foreign keys to help make sure that the data in our database is correct and to enforce it at the database level. We could, of course, go into the application layer and enforce our business rules there. And this is actually a big topic of debate among people sometimes. And I think the truth is that different applications have different needs for data integrity and for enforcing constraints. And there can be cases where you want to do this in the application layer for performance reasons as well. But there are definitely times when you want to absolutely ensure in the database layer that the rows in your database meet certain requirements. So we'll look at what those requirements are. Now, I've got a lot of rules written on the screen here, but we're going to look at a pretty simple situation to start at. This is a couple of tables from a restored copy of the Stack Overflow database. And here we have a parent table named PostTypes, and that's a really small little table that has a bunch of rows that say, okay, here's the different types of posts that there can be. Maybe ID 1 is questions, and maybe ID 2, for example, the type column says answers. And we could also have other types of posts like comments and things like that. By doing this, check out our child table posts. We can actually store both questions and answers in the post tables as long as they have different post type IDs, which indicate, is this a question or is this an answer? But we might want to have a rule that says, okay, the post table can only have a certain list of post type IDs in there. The post type ID for every row in the post column must have a corresponding row in the post types table. That is a foreign key relationship in SQL Server where we can create a foreign key on the child table, in this case post, that when we insert a row into the post table, it actually goes and says, oh, I got to check and make sure that this post type ID is valid and that it's in the parent. Now, of course, checking that on every insert is work. And that's why, like I said, there can be debate about whether we want to have these in the database and whether we want to make our database check for every row when I insert it, is this a valid row in the parent table? But of course, that does give us great confidence that our data is valid because, oops, if I'm doing all of my business rules in the application layer, maybe that isn't rock solid, and that can be a really big deal. Notice that it also lets us do something else. In the post types table, we've normalized our data. The name of the type is a Unicode value that can be a little bit long. This isn't the biggest column in the world, but we're storing an ID that's an integer, which is smaller. This lets us, in the post table, instead of storing that long value for the name of the type, just store the smaller integer value. And in practice, in our application, many times we may actually not always do this join. We may actually know what some of our most common post types are, depending on how our application works. So foreign keys change performance. And I already mentioned that, of course, when we do an insert, we have to make sure if we have a foreign key that it's valid. But there's a couple sneakier things that SQL Server can do that are kind of cool that can change performance even for select queries that are just reading data for queries that use joins between these two tables. Now, sometimes, I'm not saying this happens all the times, but let me give you an example of one query that this might help. So to start out, we don't have a foreign key. We have not told SQL Server that there's any relationship between these two tables, and it is totally possible right now, because of the lack of foreign key, it's totally possible that we might have all sorts of post type IDs in the post table where there's no corresponding row in the post types table. SQL Server has no way of knowing because we have not enforced a key relationship that makes it check. So we're going to run a select query that joins posts to post types and says, I want to count all of the rows in the post table, and I want to group things by the post type ID. So show me how many posts I have for each post type. And by the way, please make sure that there's a corresponding row in the post type table. Well, since I haven't created a foreign key relationship, when I run this query, I have to not only look at the post table and look at, I'm grouping every post by its post type ID. So I got to do a scan, and it has figured out that there's a non-clustered index it can scan, which is faster than scanning the clustered index. But I've got that nested loop in there. I've got to go check the post type table, right? Because I only want to return rows where there's, the join succeeds. So I've got to do that work. If I create a foreign key relationship, I'm creating the foreign key on the post table, and I'm telling it, you now have a constraint where the post type ID column, the value in there, must have a corresponding value in the ID column on the post type table. After I create that foreign key relationship, if I run the same query, I have now told SQL Server that there is a relationship between these two tables, and that every row in the post table definitely has that it meets this join criteria. So it can actually do something really cool and look at this and say, oh, you know what? I don't even have to execute that join because the foreign key relationship guarantees it has a corresponding row there. And the execution plan for this query looks like what you see here on the screen. There is no longer a nested loop lookup to go check the post type ID table. It's able to just eliminate that join based on the foreign key because it knows it's guaranteed, which is very, very cool. Now the foreign key, of course, means that now if I try to insert something into the post table, and apologies, there's the wrong word is colored red on this slide. So post type ID should be colored red. This is attempting to insert a post type ID of 100, which is not in the corresponding table. I can now get an error like this that says, hey, your insert failed because there is no corresponding row in the parent table, right? I cannot put invalid data in there. But what if I need to load a bunch of data? Now, maybe I want to insert data into posts and then go fix up post type ID later, or perhaps I actually just want to insert a lot of data into the post table and I don't want to check it row by row as I do the insert. After the end, I want to go back and check it in one fell swoop. But for performance reasons, I want to see if I can do a big insert and then go check it later. I don't have to just drop the constraint. You can use NOCHECK. See this syntax, alter the table, NOCHECK the constraint. And this is saying, okay, well, the constraint, the definition's still there, but it's don't check it. And now that I've done that, I can add that row. I run my insert again that inserts the post type ID 100, which before gave me an error. And now it succeeds. And see how it does the cluster index insert? It is not going off and checking that parent table at all. Now, of course, this could make me end up with invalid data if I don't also add that post type ID to the parent table, right? So let's say I go back and I'm like, okay, well, I did my NOCHECK, I did my data modifications, and now I need to re-enable the foreign key. To do this properly, what I need to do is use this syntax, and you can get this syntax half right. So here's the syntax you should use when re-enabling a foreign key. What you want to do is say, alter the table posts with check. And this syntax looks really weird because I have a line break in here, but look, essentially I have like with check, check constraint, which looks really funny. This is correct syntax. What I'm saying is I want this check, I want this constraint to be back, and I want you to check every row in the table. Now I put in that value of 100 that doesn't have a parent table. And since I've said with check, it's looking and comparing the values between the two tables, and it says, hey, you've got data in here that doesn't match. And that's what you want to know. You want to re-enable it with check to trust the constraint, because it has to actually to know that the constraint is valid for all the rows in the table. It has to actually check every row, which is a lot of work, but is absolutely useful. So I tried to re-enable this and it didn't work, right? I didn't check the constraint. And if the constraint is not enabled and trusted, I can't do that foreign key join elimination. The foreign key has to be in a state where it is both enabled and it has checked all the rows in the table to do that cool join elimination that we saw. If I delete the row that violates the key, Or of course I could add a corresponding row to the parent table. In this syntax, you can see I deleted the post with that row that I'd added before. Now I can alter the table with check and check the constraint. That re-enables my constraint and checks. And now I can get that query plan back that has the join elimination. So make sure that your constraints are not only enabled, but that they're also trusted. There is a downside to checking, right? I don't want it to seem like this is free. The post table is not a small table. Lots of people ask questions and answer questions on Stack Overflow, and looking at every row and comparing those values is a bunch of work. It also requires a heavy lock, because if you think about it, this makes sense. If I'm validating that all the rows in a child table have corresponding rows in a parent table, do I want to let anybody change the rows while I'm doing this? This is a view of an extended events trace that, this is totally just a test server. I ran a lock level trace, which is very expensive, generates a lot of rows, right? But on a test instance, and I said, for my session that's checking the constraint, show me the lock modes that are used. And it needed a schema modification lock on the child table, on the parent table, and the foreign key constraint itself, because it needs to be certain that stuff isn't messing around with this table. This is a very high exclusive lock that at the end of it, the data is valid. So we don't want to just be constantly rechecking constraints unless we're in, this is exclusive maintenance window type territory for this. And the larger the object, the longer it may take to check it, right? I also wanted to be clear that join elimination doesn't always happen. Sometimes you might do a join between these two tables, but add a where clause, or there might be a multi-column key. There might be a situation where you don't always get join elimination. I think of join elimination really as kind of a bonus if you need the foreign keys for referential integrity, right, in an OLTP type system. I don't think of the join elimination as reasons that you might add this to a data warehouse where it's not a source system, it's a downstream system. Typically, you want to enforce referential integrity in a source system, not saying this is going to tune every single query in a data warehouse. One other thing you can do when adding foreign keys is you can use something called cascading updates and deletes. And I get questions about this a bunch. A cascading update and delete says when I create this foreign key on the child table, remember I'm always creating the foreign key on the child. Let's say that I want to be able to maybe delete a post type from the parent table. This post type is no longer valid. We no longer have answers. We now live in a world where we only have questions. Doing cascading deletes tells the child table if a row is deleted in the parent, go ahead and cascade it down and delete all the corresponding rows in the child table. If, before I had answers and now answers are no longer valid and that type gets deleted from post types, go ahead and delete, cascade down all the deletes to the child table and delete from there too. Here's the syntax that you use to set up cascading deletes when you create the foreign key. So when I create the foreign key, I say, what column is it on? What is referenced? And on delete cascade. Now this means, here's an example, deleting from the post type table. And in this case, it's where ID equals 5. That's not actually answers, but that's other things where the ID equals 5. And in the execution plan, you can see there's a clustered index delete against the post type table. And then in the lower part, see, actually, the post type table is just a few rows. The post table is much larger, and there's not that many rows for the type of 5, but there's a few, and it's got to go find the rows that it wants to delete and then do a clustered index delete from posts, as well as, handle rows in the non-clustered indexes I have on post 2. So this shows that delete operation against post type does indeed cascade down to the larger set of rows on the child table. Now behind the scenes, in order to do this is another view into the locks that are being used, just run against a test system. You can see that one of the lock modes used is a range level lock. And there is actually a reason for this. I've actually heard about this issue from someone who I used to work with before about, hey, have you ever seen these strange serializable locks when certain cascading options are happening? There's a blog post that Connor Cunningham wrote. He's on the SQL Server engine team, or optimizer team. I may get the team name wrong. He's on the SQL Server team. And he wrote a post that explains, yes, even if you are not using serializable isolation level in the statement that does the delete, right? When I ran this delete, I was using the default isolation level of read committed. But he explains that there's something called an isolation level upgrade that can happen where ranged locks have to be taken out to protect this, to make sure that it's properly cascading the delete. And this helps it make sure that it maintains the data integrity. What you might have a problem with is if you have an app that probably isn't exactly like what we've been looking at with the post and the post table, but if you're frequently cascading deletes down, and you might have an issue with blocking with these key range locks fighting with one another with different queries doing things. So the takeaway here is cascading deletes, I mean, of course, you have to make sure that you really want to commit to it, right? If I delete one row in the post type table, do I really want to delete all answers in the related tables? You're committing to that, right? So first of all, just make sure it's okay. But also look at how frequently will this actually be executed, and should we performance test this to make sure that we aren't going to run into a contention problem because we may have a higher level lock type than we'd bargained for with these deletes. You could code your application so that when you need to make these changes, your application goes and handles the child rows. If it's going to be a lot, perhaps, using special methods to make sure that you're not biting off more than you can chew, and then handles the parent rows, right? So you could have a foreign key without cascading the deletes. You're just going to have to write your application to handle it and make sure that your data is bound. Now, finally, what about indexes with foreign keys? I get some questions about this because folks will hear you should always index your foreign keys, and they aren't exactly sure what that means. So here's essentially what the question is. In our case, our parent table, right, ID is already a clustered primary key. We already have an index on the parent table on ID, and if we're going to query the parent table, yes, we can go straight to that ID. When people ask this question about indexing the foreign key, what they're really asking about is on the child table, on PostTypeId in this example, do I really need to index PostTypeId? And the answer is really usually, but maybe not always, but there are good reasons you might want to. For the purpose of an insert, if I'm just going to insert a row into posts, I need to go check and see if the related value exists in the parent, and that'll use the index on the parent. But what if I'm running a select query that joins between these two? Well, that might want an index on the child table, right? But I also might want an index even for creating the foreign key. Here is the secret execution plan that SQL Server used behind the scenes when I created this foreign key. I already had an index on the post table, on PostTypeId. And when I created the foreign key, it had to go check. First, it had to check the post types table and look at the foreign keys there, but then it had to check every row in posts. And it was smart enough to realize, hey, all the columns I need to check this are actually in this non-clustered index. So instead of scanning the whole clustered index, I'll use this non-clustered index to validate the data and make sure that I can create this foreign key. So very, very cool. So if I already knew that I wanted a non-clustered index to support queries that were going to say where PostTypeId equals to or whatever, or join on the child table, and I already knew I was going to index it, in terms of the order I would actually create things in, I'm better off creating the index before I create the foreign key, because the index not only helps me join between the two tables, it can also help me create the foreign key without having to scan quite as much data too. So it can be beneficial, absolutely, to create indexes on that. Like any index, you can check and see, are queries using this? Is the SQL Server optimizer finding it useful? All right, so what, kind of gathering up the nuggets we've learned about foreign keys today. Do consider indexing the foreign key columns on your child tables. That often can be very, very useful. Be careful about implementing cascading updates and deletes, especially if they're frequently going to be used. Don't just assume that that's exactly what you should do all the time. Know that that isolation level can be upgraded to serializable to carry that out, and that you could end up with some blocking problems, deadlocks, that kind of thing. And always check your foreign keys to make sure that they're trusted, because what happens a lot is that people use NOCHECK on these to do a maintenance window, and then when they turn them back on, they don't get that syntax right and use the with check. So here's what I want you to do after this video. I want you to check your foreign keys, which you can do in a really simple query that looks and says, is this foreign key trusted or not? To get the syntax to check your foreign keys and see if they're trusted, go to brentozar.com/go/trust. Thanks for joining me today. See you again soon.